Hello, welcome to PhyzQuest. So this is the solution video for CSIR NET December 2019 Part B, question number 25. The question is, the figure below shows a 2-bit simultaneous analog to digital converter operating in the voltage range 0 to V0. The output of the comparators are C1, C2 and C3 with the reference inputs V0 by 4, V0 by 2 and 3V0 by 4 respectively. We need to find out the logic expression for the output corresponding to the less significant bit. 4 combinations are given and we need to choose the correct combination. So let's get started. This question comes from the section electronics and the concept involved here is the digital electronics. So in this question we have a 2-bit simultaneous analog to digital converter. So an analog to digital converter converts analog electric signal to digital signal by converting the analog signal into a certain number of digital bits. So if we have a n-bit analog to digital converter, it will convert the signal, the analog signal, into n number of bits, where each bit has certain weightage, starting with most certain bit with the highest weightage up to the most significant weight with the highest weightage up to the least significant weight with the lowest weightage. So in this case we have a 2-bit analog to digital converter. So that means the digital output will be in form of 2 number of bits, as you can see in the circuit, where the first bit will be the most significant bit or more significant bit, and the second bit will be the least or the less significant bit. Now when the digital output is expressed in terms of 2 bits, there will be 4 combination. So the combination will be 0, 0, 0, 1, 1, 0, 1 and 1. So these are the 4 combinations which can be possible in case of a 2-bit, 2 number of bits. So here we have a simultaneous analog to digital converter, which is also called a flash converter, flash analog to digital converter. So now in case of a n-bit flash analog to digital converter, it divides the voltage into 2 to the power n equal number of parts, and there will be 2 to the power n minus 1 number of comparators which compare each part with the reference voltage given to it. Now here we have a 2-bit flash analog to digital converter, and here the analog voltage or the input voltage is ranging from 0 to V0. That means this 2-bit flash analog to digital converter will divide the voltage into 2 to the power 2, which is equal to 4 equal parts. So when it is divided into 4 equal parts, it will be like from 0 to V0 by 4, V0 by 4 to 2V0 by 4 or V0 by 2, then V0 by 2 to 3V0 by 4 and 3V0 by 4 to V0. So these are the 4 parts it can get divided into. Now these parts will be fed to a set of comparators. Now there will be 2 to the power 2 minus 1, which is equal to 4 minus 1, that is 3 comparator, as you can see. So now here the fundamental principle of a comparator is it compares 2 voltages and produces an output either 1 or 0. Now out of the 2 voltages it compares, one of them is the reference voltage, let us say Vref, and second is the input voltage, let us suppose Vi. So if Vi is greater than Vref, then the output will be equal to 1, and if the Vi is less than Vref, then the output will be equal to 0. Here 1 and 0 means if the input voltage is higher than the reference voltage, comparator will be in on state, and if input voltage is less than the reference voltage, comparator will be in off state. So that on and off is signifying with 1 and 0. So in this case, in the given circuit, each of the comparator has a reference voltage. So as you can see here, these are the reference voltage of the comparator. So the first has now the reference voltage V0 by 4, second has V0 by 2, and third has 3V0 by 4. So the input voltage, which is divided into 4 parts, will pass through these 3 comparators. So the comparator compares each part with its reference voltage and produces the output accordingly. Now the output of these comparators are C1, C2 and C3. Now for different part of the analog voltage, the output C1, C2 and C3 will vary. So first of all, we will write down the output C1, C2 and C3 for different range of analog voltage that the comparator will produce. So first of all, let's write it down. So this is C1, C2, C3. Now suppose we consider the first comparator C1, this comparator. So when we consider the analog voltage for the when the voltage range of the input voltage range is in between 0 to V0 by 4. So here for this range of the analog voltage, the voltage is less than the reference voltage of this first comparator, which is V0 by 4. So that means we can say that the output C1 for this part of voltage will be 0 because the comparator will be in off state. Similarly, for the analog voltage range from V0 by 4 to V0 by 2, it will be higher than the reference voltage V0 by 4. That means the comparator will be on. So here the output C1 will be 1. Similarly, for these two ranges, that is V0 by 2 to 3V0 by 4 and 3V0 by 4 to V0, here the output again will be 1 because in both the cases the voltage range is higher than the reference voltage of the first comparator. Similarly, for second and the third comparator, the output C2 and C3 will be like this. This is as per their reference voltage because they have higher value of the reference voltage. Now we have got the possible output of C1, C2 and C3 of the comparator for different range or different part of analog voltage range. Okay. So this output of the comparator is fed to a coding network plus read gate plus the flip-flops, and finally it produces a digital output. Our question is to find out the logic expression corresponding to the less significant bit. That is, we are considering this one. So out of the 4 digital output combination, out of these there are the 4 combinations 0, 0, 0, 1, 1, 0 and 1, 1. These 2 combinations will have an output for the less significant bit, that is 0, 1 and 1, 1. So these two have a output for the second bit or the less significant bit. So now the simplest way to solve this is to note down the C1, C2 and C3 value for these two cases and check with all the 4 given options. So these are the 4 options which are given. So what we will do is we will put the C1, C2, C3. We have 2 set of values, this one and this one. So for each set of value we will check for all the 4 options what are the output they are giving. and the option which will give the output 1 for both the sets. For this set and for this set, the option which will give the output 1 will be our answer. So when we check that by using the value of C1, C2 and C3, the two set of values of C1, C2 and C3 in the 4 options, the values came like this. So as you can see, for this combination of logic gate, we have got the output 1 and 1 in for both the set of combinations of C1, C2, C3. Okay, for rest of them, either they are 0 or one of them is 1. But in this case, for both the set of values, we have got the answer 1. So this is our correct logic gate expression. Now let's check the option. So here, as you can see, we have got the option 3 as the correct combination. So answer is option C. Okay.